Alright, so let's talk about a use for these antiderivatives. Alright, so this is the first time we've seen this type of problem. It says solve the differential equation. We'll see these a lot throughout the year, but this is the first time, so this is a really important one. If we want to solve the differential equation, basically what they're asking us to do is find the function, find f of x. Right? So when we start out, we have to be given certain types of information. In this case, we're given this information. All right, we're given that the second derivative of x, second derivative of f of x is 3x squared. The first derivative of f at 0 equals 2, and f of 2 equals 5. And we'll see here in a moment why we want to find this, or why we need those values, I'm sorry. But you can start to already see that if we want to find f of x, and we start with f double prime of x, we're going to have to integrate 2 times to get to f of x. Alright, so think about that for a second. If we started with f of x, we'd have to take the derivative once to get f prime, and a second time to get f double prime. So here, in order to go from f double prime to f of x, we have to integrate twice. We have to find antiderivative twice. And again, we won't see for a moment yet why we need these, or where they come in, but we will here in a second. Alright, so let's look at how we would start this one off. We're going to take, we want to find the first derivative. So to find the first derivative, we have to find the indefinite integral of the second derivative. And really this should have a dx after that f double prime. Right? I probably should have mentioned this in the first section of the notes when we first introduced this notation, but this can be confusing for some students. This integral sign is really just, think of it as a stretched out S. It really stands for summation. The integral symbol and the dx are like bookends for the thing that we're finding the antiderivative of. Right? So we're finding the antiderivative of, or the indefinite integral of f double prime. F double prime is 3x squared. So it's the integral of 3x squared dx. Now, as soon as we actually take the antiderivative, which I've done here, notice I just keep that coefficient in front. I take the x squared, I add 1 to the exponent, and I divide by the new exponent. Right? Notice that I haven't bothered to simplify this yet. Take the time to do this in a couple steps so that you don't get confused. But notice here that as soon as I take the antiderivative, the integral sign and the dx disappear because I've performed that operation, so they're not there anymore. And as soon as those disappear for an indefinite integral, the plus c appears. Alright, so that all happens in one step. These two things disappear, I take the antiderivative, I have the plus c. Now I can worry about simplifying this out a little bit. Right, it's a simple one. We get x cubed plus 7. So what we have now is we know that f prime of x equals x cubed plus some constant. Right, this is not unlike if I know the slope of a line in a point, but I don't know what the y-intercept is, and that's what I want to find. I have to solve for c. So now I say, okay, well, how do I solve for c? Well, they did give me f prime of 0 up here as part of the information they gave me in the initial problem. So I take that information, I know that's 2, and I plug in 0 for the x. So I get 0 plus c is 2, so the c value is 2, and therefore I know that the specific first derivative that I have for this problem, given these initial conditions, is x cubed plus 2. Right? I wouldn't know that just from looking at the second derivative. I need this additional information that tells me what f prime of 0 was. Right? Now we're going to start with that x cubed plus 2, and I want f of x. So in order to find f of x, I have to take the indefinite integral again. So that, keep in mind, this is x cubed plus 2, and the indefinite integral of that. So I find the antiderivative, the indefinite integral of each term there. So x cubed becomes x to the fourth divided by 4. Add 1 to the exponent, divide by the new exponent. The antiderivative of 2, this is like 2 times x to the 0. So I add 1 to the exponent, divide by the new exponent. It's x to the first divided by 1 with a coefficient of 2 still. And again here, I have f is equal to this plus c. And I don't yet know what c is, but I have been given this information, f of 2 equals 5. So I say, all right, well, f of 2 equals, I substitute a 2 in for the x. So 2 to the fourth divided by 4. I get 4 plus 2 times 2 is 4 plus c equals 5. So I get c equals negative 3. So finally, my function itself, f of x, is 1/4 x to the fourth plus 2x, and my c value is minus 3. All right, so that is the solution to that differential equation here with these initial conditions here and here.